They buried an entire river beneath steel and concrete. They silenced salmon migrations that had thrived for millennia. And for 100 years, no one thought nature would ever return. Until it did. What followed wasn't just a recovery. It was one of the boldest ecological experiments ever attempted. One that risked everything to find out. Can nature really bounce back after a century of silence? This wasn't just a river. It was a question, a challenge, a mystery that scientists, indigenous leaders, and ecologists were willing to risk everything to solve. The Elwha River winds 45 miles through Washington's Olympic Peninsula, carving its way from snow-capped peaks to the sea. It once held one of the most productive salmon runs on the West Coast, over 400,000 fish annually. These fish were not just food, they were nutrient engines, bringing marine energy to mountain ecosystems. When they spawned and died, their bodies fed trees, eagles, and bears. Scientists discovered that nitrogen and phosphorus from salmon carcasses were absorbed by nearby forest plants, boosting tree growth. The Elwha was an artery, pumping life into everything around it. When the Elwha Dam was built in 1913, followed by the Glines Canyon Dam in 1927, the priority was power, not ecology. No fish ladders were included, despite warnings from locals and tribes. That sealed off more than 90% of the Elwha's spawning habitat. Salmon returning from the ocean slammed into concrete. Generation after generation disappeared. Before the dams, massive Chinook, some over 100 pounds, were common. Afterward, their numbers collapsed. By the 1980s, the once great run had fallen to fewer than 3,000 fish per year. Entire species of insects and birds dependent on salmon nutrients declined. Juvenile fish couldn't migrate properly. The river lost its rhythm. The Elwha River Ecosystem and Fisheries Restoration Act passed in 1992 after decades of activism. It was one of the first federal acknowledgments that some infrastructure should be removed, not repaired. Opposition was fierce. Critics warned of mudslides, water pollution, and wasted investment. But proponents argued that the long-term ecological value and cultural restoration was worth it. The lower Elwha Clallam tribe played a central role in this shift. Their legal, scientific, and cultural leadership reframed the project as more than an experiment. It was a reconciliation. Federal agencies joined forces with tribal experts and environmental scientists. They created adaptive strategies and modeled sediment flows, fish recolonization, and native vegetation regrowth before any demolition began. Demolition began on September 17, 2011, a carefully staged deconstruction. The Elwha Dam was removed within a year. The larger Glines Canyon Dam took until 2014. It wasn't just about removing concrete. Engineers had to manage the release of 10.5 million metric tons of trapped sediment. That sediment had built up behind the dams for nearly a century, layer upon layer of riverbed history. Releasing it too fast could have smothered fish habitats downstream. Releasing it too slow could delay the river's healing. Crews used phased blasting, dredging, and hydraulic drawdown to guide the river's rebirth. By 2015, sediment had traveled over 13 miles downstream, rebuilding beaches and reshaping the river delta. Satellite images showed dramatic growth of the estuary. Nature wasn't just reacting, it was reshaping itself. As waters receded, old lake beds were exposed, brown, cracked, and barren. But within weeks, green shoots emerged. Buried seed banks awoke. Birds returned to scatter more seeds. Pollinators followed. By 2018, over 90% of the dewatered area was covered in vegetation. Native species like black cottonwood, red alder, and bigleaf maple began stabilizing the new floodplain. Over 300,000 native plants were hand-planted by restoration crews, but many more came from natural recolonization. Monitoring showed plant cover increasing at rates of 20 to 35% per year in key zones. Surprisingly, invasive species didn't dominate. Experts say that the sediment's mineral composition, combined with early-stage native seeding, gave native plants the edge. What was once a reservoir became a young forest. The salmon returned faster than anyone dared hope. In the fall of 2012, less than a year after dam removal began, coho salmon were spotted spawning upstream of the former Elwha Dam. Steelhead followed. By 2014, pink salmon were seen 30 miles upriver. Chinook, the iconic giants of the Elwha, are recovering slowly. But the signs are good. Spawning surveys show their natural reproduction increasing each year, with peak runs exceeding 3,000 individuals in some seasons. Tagging studies confirm that juveniles are surviving and making it to the ocean. By 2023, over 65 kilometers of habitat had been recolonized. That includes tributaries that hadn't seen salmon in over 100 years. The Elwha became one of the most monitored river systems on Earth. Researchers used drone LiDAR to track vegetation changes. They set up riverbed sensors to measure sediment depth. They tracked fish using pit tags, sonar, and acoustic telemetry. USGS established long-term monitoring plots that captured everything from insect populations to water chemistry. The National Park Service tracked wildlife recolonization. Data from over 40 monitoring stations feeds into an open-source portal used by ecologists globally. One surprising result: beach widths near the river mouth increased by over 300 feet in places due to new sediment. This helped protect coastal areas from storm surges, an unexpected climate resilience benefit. Wildlife responded in waves. Otters moved into new side channels. Deer grazed in newly grown meadows. Beavers returned, reshaping hydrology with their dams. Insect diversity doubled. Amphibians found new breeding ponds. Ecosystems didn't just recover, they diversified. A 2021 study recorded a 35% increase in bird species richness along the restored floodplain. Even aquatic macroinvertebrates, the insects that fish rely on, bounced back to pre-dam levels within 3 years. For the lower Elwha Clallam tribe, this was healing. Ceremony returned to places once flooded. Ancestral stories could now be walked, not just told. What the river gave back was more than life. It was memory. At $351 million, the Elwha project wasn't cheap, but it proved something priceless, that restoration on a grand scale works. It inspired similar removals across the U.S., like the Klamath River dams in California and the Penobscot project in Maine. It shifted policy. Infrastructure funding now includes ecological restoration. It also reframed public thinking, from dams as permanent to dams as negotiable. But most importantly, it gave hope that ecosystems can return, that science and culture can align, that rivers remember. And if we listen, they will show us how to begin again. And if you were as shocked and hopeful by this extraordinary story as we were, make sure to like this video, share it widely with your friends, and subscribe for more world-changing revelations about our planet's future.